Hello everyone, in this video we're gonna review Unit 7 AP Calculus BC topic 7.5 Euler's method and 7.9 Logistic models with differential equations. Alright, let's move on to question 1. This question comes from AP Calculus BC exam 2004 question 5. A population is modeled by a function p that satisfies the logistic differential equation. Question A. If p of 0 equals 3, what is limit of p of t when t approaches infinity? If p of 0 equals 20, what is the limit of p of t when t approaches infinity? Alright, so before we're going to do this question, let's review the logistic models with differential equation. Alright, this is 7.9 logistic models with differential equations. So, the logistic model differential equation forms is given by the formula dy over dt equals k times y times 1 minus y over L. Logistic growth equation forms is given by this formula. Alright, in either form, L represents the carrying capacity. This one is extremely important, right? So L right here and L right here. Or upper limit of the logistic growth equation. A logistic growth curve increases the fastest when the curve reaches half its carrying capacity L. So we look at the graph right here. The horizontal line right here is called the carrying capacity. It looks like a horizontal asymptote, right? And the logistic growth increases fastest when the curve reaches half of carrying capacity, right? So for example, the distance from here to here is the carrying capacity. It's gonna be like 20, alright? So the logistic curve growth increase fastest when it's gonna be 10, right? Half of 20, which means 10, right? Now we're gonna go back over here. So in order to answer question A, we need to rewrite this one, right? So this one can be written as 1 over 5 p, right? Times 1 minus p over 12, right? Remember, the logistic model is given by the formula dy over dt equals k times y times 1 minus y over L, right? So in this situation, L equals 12, right? So the limit of p of t when t approaches infinity equals L, which is 12, right? This one is the same thing, 12, right? If p of 0 equals 3, for what value of p is the population growing the fastest, right? So the logistic model's growth increase fastest when it reaches half of carrying capacity, right? So carrying capacity is 12, right? So this guy should be 6, right? Then you can conclude that P equals 6, right? Now let's move on to question C. A different population is modeled by a function y that satisfies the separable differential equation dy over dt equals y over 5 times 1 minus t over 12. Find y of t if y of 0 equals 3. Now to solve for y of t, we need to separate the variable by multiplying both sides by dt and dividing both sides by y, right? So this guy becomes dy y over y equals 1 over 5 times 1 minus t over 12 times dt, right? And then we're gonna integrate both sides, right? So the left hand side turns out to be ln absolute value of y equals. Now the right hand side, I just print 1 over 5 to the front, right? Antiderivative of 1, which is t, right? Antiderivative of this one, which is rewrite 1 over 12, right? Multiply by t squared over 2, right? Plus c, right? Now I'm going to simplify this one, so it could be ln absolute value of y equals 1 over 5t, right? Minus 12 times 2, it could be 24, times 5, it could be 120, right? So it could be negative t squared over 120 plus c, right? Now 1 over 5t, I can write this one as t over 5, right? Now I'm going to exponentiate both sides, right? So this guy becomes e to the this guy and e to this guy, right? So I'm going to apply the formula a to the log base a of b equals b, right? Because ln is going to be log base e, right? So log base e is of absolute value of y, and then this one is e. It's going to be absolute value of y, right? So this guy becomes absolute value of y equals e to the t over 5 minus t squared over 120 times e to the c, right? Remember, you have the formula a power of m plus n. It's going to be a power of m times a power of n, right? Keep that in mind. Now I'm going to name e to the c as a, right? So this guy becomes absolute value of y equals a times e to the t over 5 minus t squared over 120, right? Now I'm going to use initial condition right here. Alright, initial condition is positive, right? So I can remove the absolute value bars right here without changing anything, right? So I have y equals a times e. Now this one right here, I can rewrite this one first and this one next, right? So I can write like this, negative t squared over 120 plus t over 5, right? Now I'm going to use initial condition right here to solve for a, right? So I have 3 equals a times e, 0, right? So a equals 3, right? And the final equation should be y equals 3 times e to the negative t squared over 120 plus t over 5. This one is the final answer, right? Now question D. For the function y found in part C, what is the limit of y of t when t approaches infinity, right? So basically, we just find the limit of this function, right? So limit of y of t when t approaches infinity equals limit of 3 times e to the negative t squared over 120 plus t over 5, right? When t approaches infinity. This guy is the same thing as limit when t approaches infinity of 3. I can bring this one to the bottom. So it could be e to the t squared over 120 minus t over 5, right? So I can rewrite this one as limit when t approaches infinity of 3 over e to the. Now I can rewrite this one and this one at the same denominator, right? So denominator is 120, right? And this guy becomes t squared minus 24t, right? Now when t approaches infinity, this guy right here faster than this guy, so we can ignore this guy, right? So this guy becomes 3 over infinity, right? And it's gonna be 0, right? Now let's move on to question 2. This one comes from AP Calculus BC exam 2009, question 4. Consider the differential equation dy over dx equals 6x squared minus x squared y. Let y equals f of s be a particular solution to the differential equation with the initial condition f of -1 equals 2. Use the Euler's method with two steps of equal sign starting at s equals -1 to approximate f of 0, right? So in order to do this problem, we need to sketch the table. Alright, so first you need to calculate delta S, right? It's gonna be B minus A divided by N, right? Now B equals 0 right here is the final one, right? And A equals -1 right here, right? And it's gonna be two steps of equal sign, so N equals 2, right? So you have 0 minus -1 divided by 2, so it could be 0.5, right? Now we're gonna start with the initial value, which is s equals -1 right here, right? And you keep adding 0.5 each time until you reach the final one, 0 right here, right? So you add 0.5, it's gonna be -0.5, right? And add 0.5, it's gonna be 0 right here, and you stop, right? And then the final values is right here. This is what you need to find, right? So at initial value s equals -1, y equals 2, you just put 2 over here, right? So you're gonna substitute -1 and 2 into differential equation right here to find dy over dx, right? So if you substitute over here, it's gonna be 6 minus 2, so it's gonna be 4, right? And then equation of the tangent line is going to be y minus y1 equals m times s minus s1, right? S1 is right here, y1 is right here, the slope is right here. You just substitute over here, right? So you're going to have y minus 2 equals 4 times s plus 1, right? Now you need to substitute -0.5 for s into this equation to solve for y right here, right? So if I substitute over there, I will get the new y should be 4, right? So I put 4 right here, right? Now you have the new s, new y, and you need to calculate new dy over dx, right? So substitute -0.5 for s and 4 for y into the differential equation right here, and you get the new dy over dx is actually 0.5, right? And then you apply this formula right here, so it could be y minus 4 equals 0.5 times s plus 0.5, right? And then you substitute 0 for s into this equation right here, so you're gonna get 4.25, right? So finally, the question mark right here should be 4.25. You stop right here. This one is the final answer, right? Question B. At the point -1 and 2, the value of the second derivative is -12. Find the second degree Taylor polynomial for the function f about s equals -1. Alright, so this topic actually you learn in Unit 10 Taylor and Markov series. Question B. Alright, so you have the Taylor series is given by the formula f of s equals sigma notation of f n of a over n factorial times s minus a to the n when n goes from 0 to infinity. Now we're going to expand this formula. If n equals 0, substitute 0 for n, you only have f of a, right? If n equals 1, you have f prime of a times s minus a, right? Because 0 factorial equals 1 factorial equals 1. So keep that in mind. If n equals 2, you have f double prime over 2 factorial times s minus a square, right? If n equals 3, you're going to have f triple prime of a over 3 factorial times s minus a cube plus etc. Right? Now, the question just want you to find the second degree Taylor polynomial, which is you're gonna stop right here. This one enough. Now this one is the Taylor series for f of s about s equals a, right? So you have a right here, you have a right here, right? Now, in this situation, s equals -1. Substitute -1 for a into this one right here, right? So you have p2 equals f of -1 plus f prime of -1 times s minus -1, which is plus 1, right? Plus f double prime of -1 over 2 factorial of s minus -1, which is plus 1 altogether square, right? Now to find the answer, we need to solve for f of -1, right? F of -1 is given right here. It's going to be 2 plus f prime of -1. We're going to use the order pair right here, right? So we substitute this guy into this equation right here, right? But we already calculated it's right here, actually 4 right here, right? So we have 4 times s plus 1, right? Plus f double prime of -1, right? It's going to be right here, -12. -12 divided by 2 factorial, it's going to be 2 times 1, right? So it can be -6, right? Times s plus 1 square, right? So I just simplify this one. It turns out to be 2 plus 4 times s plus 1 minus 6 times s plus 1 square. This one is the second degree Taylor polynomial, right? Now question C. Find the particular solution y equals f of s to the given differential equation with the initial condition f of -1 equals 2. Now we need to separate the variable. In order to separate the variable, you need to factor s squared out first, right? So we have dy over dx equals s squared times 6 minus y, right? So I'm going to multiply both sides by dx and divide both sides by 6 minus y, right? So it could be dy over 6 minus y equals s squared times dx, right? Now I'm going to integrate both sides, right? Now the left hand side right here, I need to apply the formula antiderivative of u prime over u du. It's going to be ln absolute value of u plus c, right? Now, in order to apply this formula, make sure this guy and this guy must be the same, right? So the bottom right here is z minus y. The top is just y right here. I need to rewrite this one as z minus y, right? So dy right here can be written as d of z minus y, right? If you check the derivative of this one, actually negative dy, right? So I put negative side right here and I put negative side in the front, right? So thing doesn't change, right? So right here, I just apply the formula right here, right? So this guy becomes negative of natural log of absolute value of z minus y equals. The right hand side, I just use the power rule, right? So it could be 1/3 as q plus c, right? I'm going to use the initial condition right here to solve for c, right? It's going to be right here. So I'm going to substitute negative 1 for s and 2 for y, right? So I have negative ln of 4 equals 1/3 of negative 1 q plus c, right? So c equals 1/3 minus ln 4, right? So then the equation right here becomes negative ln of absolute value of z minus y equals 1/3 as q plus 1/3 minus ln of 4, right? Now I'm going to multiply both sides by negative 1. So ln of absolute value of z minus y equals negative 1/3 as q minus 1/3 plus ln 4, right? Now on the right hand side right here, I just combine the first two terms right here. I factor negative 1 out, right? So I have this guy plus this guy, like that, right? Now I'm going to exponentiate both sides, right? So I have e to this one equals e to this one, right? So this guy becomes absolute value of z minus y equals e to the negative of 1/3 s cubed plus 1/3, right? Times e to the ln 4, right? Now e to the ln 4 actually 4, right? So I can bring 4 to the front. Now I need to remove the absolute value sign using the initial condition, right? So my initial condition is going to be f of negative 1 equals 2, right? I substitute 2 for y into this one, and 6 minus 2 is going to be 4. It is positive, right? So I remove the absolute value bar without changing anything, right? So I have 6 minus y equals 4 times e to the negative of 1/3 s cubed plus 1/3, right? So then y equals 6 minus 4 times e to the negative of 1/3 s cubed plus 1/3, right? Now let's move on to question 3. This comes from AP Calculus BC exam 2012 question 5. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. B of t is the weight of the bird in grams at time t days after its first weigh, then dB over dt equals 1 over 5 times 100 minus b. Let y equals b of t be the solution to the differential equation above with initial condition b of 0 equals 20. Question A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Alright, so when it comes to faster or slower, think about the first derivative, right? So we just substitute 40 for B and 70 for B into the differential equation right here. So I have question A. Now you have dB over dt when B equals 40. It's going to be 1 over 5 times 100 minus 40, right? So 100 minus 40 is going to be 60 divided by 5 is going to be 12, right? dB over dt when B equals 70 is going to be 1 over 500 subtract 70, right? So it's going to be 6. So you can conclude that the bird is gaining weight faster when its weight 40 grams, right? Because 12 greater than 6, right? Now let's move on to question B. Find the second derivative in terms of B. Use the second derivative to explain why the graph of B cannot resemble the following graph. Alright. So we have dB over dt equals 1 over 5 times 100 minus B, right? Now, the second derivative of this one becomes 1 over 5 times derivative of 100 is going to be 0. Derivative of this one is going to be negative dB over dt, right? But dB over dt equal this one, right? So it's going to be negative 1 over 5 times 1 over 5 times 100 minus B, right? Now we're going to simplify this one. It's going to be negative 1 over 25 times 100 minus B, right? We're going to look at the graph right here. We see that B is always between 20 to 100, right? So it tells us that 100 minus B must be positive, right? And then a positive number multiplied by negative 1 over 25, which is negative, right? So then the second derivative right here is negative. It tells us that the function is always concave downward, right? But you look at this one right here, original graph right here is concave upward, right? So you can conclude that the graph of B is concave down for B from 20 to 100. A portion of the given graph is concave up, right? Now let's move on to question C. Use separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20, right? Alright, so basically you divide both sides by 100 minus b and multiply both sides by dt, right? So we have db over 100 minus b equals 1 over 5 dt, right? Now we're gonna integrate both sides, right? Now remember, we need to make this one the same thing so that we can apply the formula u prime over u du. It's going to be ln absolute value of u plus c, right? So on the top right here, I can rewrite this one as d of 100 minus b, right? And if you check the derivative of this one, it's actually negative db, right? So I put negative side right here and negative side right here. So thing doesn't change, right? So this guy becomes negative ln absolute value of 100 minus b, right? Equals 1 over 5 t plus c, right? Now we're going to use the initial condition right here to find c, right? So b of 0 equals 20. So substitute over here, you have negative ln absolute value of 100 subtract 20 is going to be 80, right? Equals c. So c equals negative ln of 80, right? So then the equation becomes negative ln of absolute value of 100 minus b equals 1 over 5 t minus ln 80, right? Now I'm going to multiply both sides by negative 1. So then this guy becomes ln of absolute value of 100 minus b equals 1 over 5 t times negative 1 is going to be negative right here plus ln of 80, right? And then I'm going to exponentiate both sides, right? So I have e to this one equal e to this one, right? So it could be absolute value of 100 minus b equals e to the negative 1 over 5 t times e to the ln of 80. So actually 80, right? Now since b always greater than equal 20, less than 100, so then this guy always positive, right? So I can remove the absolute value side without changing anything, right? So I have 100 minus b equals 80 times e to the negative 1 over 5t, right? So then b equals 100 subtract 80 times e to the negative 1 over 5t. This one is the final answer. Now let's move on to question 4. This question comes from AP Calculus BC Exam 2013 question 5. Consider the differential equation dy over dx equals y squared times 2x plus 2. Let y equals fs be the particular solution to the differential equation with initial condition f0 equals negative 1. Question A. Find the limit of fs plus 1 over psi s. Show the work that leads to your answer, right? So I have question A right here. To find this limit, we need to find the limit on the top to see what happens, right? Limit of f of s plus 1 when s approaches 0. It's going to be f of 0 plus 1. It's going to be negative 1 plus 1 equals 0. Now limit of sine s when s approaches 0. It's going to be sine of 0. It's going to be 0. So we can conclude that this one is the indeterminate form, right? So we can apply the L'Hospital rule, right? So we have limit of f of s plus 1 over sine s when s approaches 0 equals limit when s approaches 0. Take derivative on the top, is going to be f prime of s. Derivative on the bottom is going to be cosine s, right? So you can substitute 0 for s, it could be f prime of 0 over cosine of 0, right? Now f prime of 0 using this one right here, right? So remember y equals negative 1, right? So substitute 0 for s and negative 1 for y. You have negative 1 square times 2 times 0 plus 2, right? Over cosine of 0 equals 1, right? So this one turns out to be 2. Now question B. Use the Euler's method starting at s equals 0 with 2 steps of equal sign to approximate f of 1/2, right? So we're going to sketch the table. We start at s equals 0, right? So a equals 0, right? And we need to calculate f of 1/2, right? So b equals 1/2, right? Now we have 2 steps of equal size, so n equals 2, right? So delta s equals b minus a divided by n, right? So it could be 1/2 minus 0 divided by 2, right? So it could be 1 over 4, right? So the step size is 1 over 4, right? So we start at 0, we keep adding 1 over 4 until we get 1 over 2, right? So this one is 0, this one is 1 over 4, and this one is 1 over 2. And we need to find the value of y when s equals 1 over 2. This one is our answer, right? Now, the initial condition is f of 0 equals -1, right? So y equals -1 right here, right? So substitute 0 for s and -1 for y into this equation right here to solve for the slope, right? So the slope should be -1 squared equals 1, right? 0 times 2 equals be 0, right? So the answer should be 2, right? So equation of the tangent line, we're going to use this one right here, right? So we have y minus -1, which is plus 1, equals 2 times s minus 0. So it could be s only, right? Substitute 1 over 4 for s, right? So you have y equals 2 times 1 over 4 minus 1, right? So it could be 1 over 2 minus 1 is going to be -1 over 2, right? So we have -1 over 2 right here, right? Now substitute these two guys into this equation right here. So we have -1 over 2 squared is going to be 1 over 4 times 2 times 1 over 4, right? Plus 2, right? So this guy becomes 1 over 2, right? 1 over 2 plus 2 is going to be 5 over 2. 5 over 2 times 1 over 4 is going to be 5 over 8, right? Now the equation of the tangent line is going to be y plus 1/2 equals, the slope is going to be 5 over 8 times s minus 1 over 4, right? We need to calculate y of 1 over 2. So it's going to be y equals 5 over 8 times 1 over 2 minus 1 over 4, subtract 1 over 2, right? So 1 over 2 minus 1 over 4 is going to be 1 over 4, right? So it will be 5 over 8 times 1 over 4 minus 1 over 2. Now 5 over 8 times 1 over 4 is going to be 5 over 32, right? Minus 1 over 2, I can rewrite this one as 16 over 32, right? So the final answer must be -11 over 32, right? So the question mark right here should be -11 over 32. This one is the final answer, right? Now question C. Find y equals f of s, the particular solution to the differential equation with initial condition f of 0 equals -1, right? So now we need to separate the variables, right? So I'm going to divide both sides by y squared and multiply both sides by ds, right? So it could be dy over y squared equals 2s plus 2 times ds, right? Now the left hand side, I can rewrite this one as antiderivative of y to the -2 dy, right? The right hand side is going to be 2 times s squared over 2 plus 2s plus c, right? Now the left hand side, I can use the power rule, right? So I have -1 over y equals s squared plus 2s plus c, right? Now I need to use the initial condition. It's going to be f of 0 equals -1, right? Substitute over here to solve for c, right? So I have 1 equals c. So c equals 1, right? So substitute back over here. So you have equation -1 over y equals s squared plus 2s plus 1, right? Now s squared plus 2s plus 1, this one actually the complete square formula, right? So we have s plus 1 altogether square equals -1 over y, right? Now I will multiply both sides by -1, right? So this guy becomes 1 over y equals -s plus 1 altogether square, right? And I flip this one, it's going to be y equals 1 over s plus 1 all together square, right? This one is the final answer. Now let's move on to question 5. AP Calculus BC Exam 2015 question number 4. Consider the differential equation dy over dx equals 2x minus y. Question A. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. Alright, so in order to do this one, remember we have the Christmas tree trick. If the line is going up, the slope is positive. The line is going down, the slope is negative. The line is horizontal, the slope is 0. The line is vertical, the slope is undefined. Right? Now on the left hand side, when the line is going up, bigger slope, steeper line, right? On the right hand side, the line is going down, smaller slope, steeper line, right? Alright, so we're gonna check this point first. This point is x equals 0, y equals 1, substitute over here, right? So we have negative 1. So the slope is negative 1, which means rise over run equals negative 1 over 1, right? So you're going to start from here, going down 1 unit, and go to the right 1 unit. So you get the slope field is going to be follow this guideline right here. So it should be something like this, right? Now next one, this point right here, x equals 0, y equals 2, you have negative 2, right? So negative 2, which means rise over run equals negative 2 over 1, right? So you're going to go down 2 units, go to the right 1 unit, right? So it could be something like this, right? So the slope field is going to be like this. So you see that this guy right here, less steep than this guy, right? Smaller slope, steeper line, right? Now next one, we're gonna check this one. X equals 0, y equals negative 1. So the slope right here equals 1, right? Which means rise over run equals 1 over 1, right? So you're gonna go up by 1, go to the right by 1. So you're gonna get this one, something like this, right? So you're gonna follow this guideline, you draw the slope field like this, right? Now next one, this point right here, x equals 1, y equals negative 1, substitute over here. So you have 2 plus 1 equals 3, right? So it could be rise over run equals 3 over 1, right? So you're going to start from here. You go up 3 units, right? 1, 2, 3. And go to the right 1 unit. So it could be right here, right? So you're going to draw this guideline right here, right? So the slope field is going to be something like this, right? Now this point right here, x equals 1, y equals 1, substitute over here, you have 1, right? So it's going to be rise over run equals 1 over 1, right? So you're going to go to the right 1 unit and go up 1 unit, right? So it could be right here, right? So you're going to follow this guideline, draw the slope field, right? Now we're going to substitute this one over here. You see that the slope is 0, right? So look at the Christmas tree, it's going to be horizontal line, right? So it could be like this. So I'm going to erase this one. Now question B. Find the second derivative in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Alright, so we know that the differential equation is given by dy over dx equals 2x minus y, right? Now we need to calculate the second derivative of this one. So we have d squared of y over dx squared equals 2 minus dy over dx, right? So then it's going to be 2 minus, but dy over dx equals this one right here, right? So it could be 2x minus y, right? So it could be 2 minus 2x plus y, right? Now go back over here in second quadrant, right? So we have the x and y coordinate right here. The second quadrant is right here, right? In this quadrant, x is negative, y is positive, right? So if x negative, you have this guy right here, positive, right? And this one right here, positive, right? And this one is already positive, right? So the whole thing right here is positive, right? So if this one positive, the second derivative is positive, right? And then the function is concave up, right? Now let's move on to question C. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Does the function f have a relative minimum, relative maximum, or neither at x equals 2? Alright, so whenever we talk about the relative minimum, relative maximum, or neither, we need to determine the first derivative, right? And this one right here must be the zero of the first derivative. So we're gonna check it. See, dy over dx equals 2x minus y, right? And then dy over dx, evaluate this one as x equals 2, y equals 3. It's going to be 2 times 2 minus 3. It's going to be 1, not equal to 0, right? So you can say that the function f has neither a relative minimum nor a relative maximum at x equals 2. Now let's move on to the question D. Find the values of the constant m and b for which y equals mx plus b is the solution to the differential equation. Alright, so we have y equals mx plus b, right? We need to take derivative both sides with respect to x, right? So we have, and then this guy becomes dy over dx equals, derivative of this one is going to be m, derivative of this one is going to be 0, right? So the final answer must be m, right? Now, dy over dx is given right here, right? It's going to be 2x minus y, right? So we have 2x minus y equals m, right? But y equals mx plus b, right? So we replace y with mx plus b, right? So we have 2x minus mx minus b equals m, right? Then I'm going to subtract m both sides. So we have 2x minus m s minus b minus m equal to 0, right? So the left hand side, I just factor s out, so it will be 2 minus m all together times s. This one I factor negative 1 out, so it will be b plus m, right? The right hand side right here, I can rewrite this one as 0 s plus 0, right? Now I can equate the coefficient both sides, right? This one has s, this one has s, so the coefficient must be the same, right? This one is the constant, this one is the constant, right? So we have a system of two equations. 2 minus m right here must be the same thing as this guy, right? Equal 0. And b plus m right here must be equal to this one, right? So we have negative of b plus m equal to 0, right? So the first equation, I have m equals 2, right? Substitute 2 for m into the second equation. So we have b plus 2 equal to 0 and b equals negative 2. So finally m equals 2 and b equals negative 2 is the final answer, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
just like tall buildings, as the chemicals they take us higher. The night's young, and it's just begun, as she puts her